Welcome to today's video on Solidity programming. In this session, we will explore the concept of inheritance in Solidity and how it can enhance code reusability and extend the functionality of your smart contracts. So let's dive in. Solidity, being an object-oriented programming language, supports inheritance between smart contracts. So this powerful feature allows you to separate and reuse code, reducing dependencies and increasing efficiency. Inheritance in Solidity involves two types of contracts, okay? The base contract and the derived contract. The base contract is the one from which other contract inherit features, while the derived contract is the one that inherits those features. Think of them as a parent-child contracts. It's important to note that the scope of inheritance in Solidity is limited to public and internal modifiers. This means that a derived contracts can access all non-private members, including state variables and internal methods, but it cannot use this keyword. Function overriding is allowed in Solidity also, as long as the function signature remains the same. However, if the output parameters differ, the compilation will fail. So make sure to pay attention to the function signature when overriding. To call the function from the super contract, you can use the super keyword or the super contract's name. This allows you to access and execute functions from the base contract within the derived contract. Solidity provides different types of inheritance. First, we have a single inheritance where the function and the variables, we will talk about it next slides. So we have here four types of inheritance: single inheritance, multi-level inheritance, hierarchical inheritance, and multiple inheritance. Let's talk about the first type, which is a single inheritance. In this type, the function and variables from one base contract are inherited into a single derived contract. Okay, this code about the program demonstrates the concept of a single inheritance. Let's break down the code and explain each part, then we will apply it in the IDE. Here, as you see, contract parent. Okay, the parent here contract is defined with a single internal state variable called sum. Okay, then we have a set value. Set value function is defined as an external function. It sets the value of the sum variable by adding two numbers, 10 and 20. Okay. Then we have the child. The child contract is defined with the keyword is, look at this, contract child is parent. So we add this followed by the name of the base contract parent. This signifies that the child contract inherits from the parent contract. Okay, so this is the child contract inherits features from parent contract. Here we have a get value function defined as external function. It returns here the value of the sum, okay, sum variable, which is inherited from the parent contract. Okay, then here we have caller contract defined to demonstrate the usage of the inherited functionality. So an instance of child contract, here we have we derived or we create an object which is CC, created an instance of the child contract. Then we have a test inheritance function is defined as a public function. It first calls the set value function of the child contract to set the value of sum. Then it calls the get value here to retrieve the value of the sum and returns it. Okay. So this program shows cases single inheritance and solidity. The child contract inherits the sum variable and the set value function from the parent contract. And then the caller contract here demonstrate the usage of the inherited functions by creating an instance of the child contract and calling the inherited functions. Let's implement this code in the IDE. Here we have a remix. I put here the code contract parent. Then here we have a child is parent, which is inherited the features from the parent contract. Then we have a contract caller. After adding this code, we should compile. Then we go to the deploy. But the first, we should go here, contract, and see we have caller, child, parent, and the deploy process will be for caller. Then deploy it. Then I will go to the test inheritance and go to the here. We can see the decode output, which is 30. Why 30? Because we have here equation sum a and a plus b, a while a 10 and the b 20. Then this could return the result of this equation, which is 30. Okay, so this is the first type of inheritance about single inheritance. Now let's move on to the next type of inheritance, which is multi-level inheritance. Multi-level inheritance, it's similar to single inheritance, but it involves a chain of a relationship between parent and child contracts. The child contracts derived from a parent can also act as a parent for another derived contract, okay? So a child here, derived child, let's think about it like this. A child here, okay, inherit from the parent class, but also can act as a parent for another derived contract. Not class, contract, okay? So let's look at this code. Contract A here is inherited by contract B. Contract B is inherited by contract C here, by contract C, okay, to demonstrate a multi-level inheritance, okay? So let's break down this code again, line by line. So here we have a contract A defined as a parent contract. It declares two state variables, X as internal variable and A and B. X internal variable and A and B, okay, as a string variables with initial values. We put initial values here, okay. Get A function defined as an external function. It concatenates the values of A and B and assigns the result to the X variable. Okay, assign the result into X variable. Now contract B defined as a child contract that inherits the A contract. So we add is, then the parent class, the parent contract. So it declares two state variable, Y as a public variable, okay, and C as a string variable with an initial value, okay. Get B function defined as an external payable function. It concatenates the value of X inherited from A, and the C assigns the result to the Y variable. About the contract C, defined as a child contract that inherits from B contract, we write like this, is, then the parent class here is B. It doesn't declare any additional state variables. Get C function defined as external view function, it simply returns the value of the Y variable, which is inherited from B. Then we have a caller. Caller here defined to demonstrate the usage of inherited functionality. An instance of C contract, CC, is created. So CC is created here. The test inheritance function is defined as a public function. Okay, it first call the getA function of the C contract to set the value of X by concatenating A and B. Then calls getB function to set the value of Y by concatenating X and C. Finally, it retains the value of Y by calling getC function. So this code or this program showcases multi-level inheritance in Solidity. The B contract inherits from an A contract and adds its own functionality. And the C contract then inherits from a B and further extends the functionality. The caller contract demonstrates the usage of the inherited function by creating an instance of the C contract and calling the inherited functions in the desired sequence. Another type of inheritance is hierarchical inheritance, where a parent contract has more than one child contract. This is useful actually when a common functionality needs to be shared among different contracts. Finally, there is a multiple inheritance where a single contract can inherit from multiple contracts. A parent contract can have multiple child contract, and the child contract can have multiple parents. Let's apply another example here about the inheritance. We have this code. Look at this code. Okay, in this code or this example, we have three contracts: base A, okay, base B, and derived. Okay, the derived contract inherits from both base A and base B, thereby demonstrating multiple inheritance. Base A and base B are base contracts that define their own state variables and constructors. Each base contract has a single state variable, A, look at this, A for base A, B for base B contract, and a constructor that initializes the respective state variables. The derived contract here, derived contract inherits from both, as I said, base A and base B using the syntax is. So we add is, base A, base B. So here inherits from two contracts, okay, using the syntax is. This syntax specifies the arguments to be passed by to the constructor of the base contract during inheritance. So in this case, derived passes 10 to the base A constructor and 20 to the base B constructor. Okay, 10 and 20. Derived contract also has its own state variable, which is C, and a constructor initializes it. Caller contracts creates an instance of the derived contract, okay, of the derived contract, and provides an example function, get values, to retrieve the values of A and B and C from derived contract. So here we have a function, get values, okay. So in this example, expected values would be what? Would be 10 for A, with 20 for B, and 30 for C. Okay, let's deploy compile this code and deploy it. Again, when deploy it, you should focus on the which contract will be deployed, base A or base B or caller. By default, base A, but we go to the caller, which is the last one, to this contract has the function get values that retrieve the values of A and B and C from derived contract. So we deploy this contract, then we go to the here, okay, and get values to check. So you can see here the values 10 and 20 and 30 also. So this is the result or the expected 10 and 20 and 30. This is the expected value would be, which is 10 and 20 and 30. Okay. So that's a brief overview of inheritance with 4 types of inheritance and solidity. By leveraging inheritance, you can enhance code organization, promote reusability, and create more powerful and modular smart contracts. I hope you found this video helpful in understanding the concept of inheritance and solidity, and thank you for watching.